Good day guys, let's have a look at another problem on theorems of geometry. So here we've got a circle with P, S, and Q on the circumference. Then TP is a tangent, O is the center. So when I pick this problem, I have to always try to figure out what are the things that will guide me to some theorems. So as I've said, I want to take those important things out of the diagram so that will guide me to my theorems. So I see a tangent in this equation. According to this equation, there is a tangent which is TP. Then as long as there is O at the center, it means QS is the diameter. So I see a diameter which is QS. Then we are also can also pick from the diagram that TPS is an angle which is 23 degrees. Then what else do I see in this diagram? I see a lot of chord. I see a lot of chord in the diagram. I see that PS is a chord, PR is a chord. I see QP as a chord, QR as a chord. I also see a radius. The radius is there, being OP. So those are the things I pick from my diagram. So I see triangles as well, and especially the fact that OP as well as OS, each of them is a radius. This is from center to circumference, center from to circumference. So that immediately tells me that there is an isosceles triangle involved in this situation. So I see a lot of triangles, QSP, I see QPR, but I also see an isosceles triangle, which is a very, very important triangle that can help you with your solving. So it means to handle this problem, I should be looking at theorems around the tangent, the chord, so that is the possibility of tan chord theorem being present. There is a diameter, I can check the theorem around diameter, which says angle subtended by a diameter. At any point in the circumference is always a right angle. TPS is just the angle that is given, the only angle given in the equation. Then I see a radius, so there is a possibility that I might have to make use of the radius, or if I don't make use of the theorem of the radius, the fact that two of them exist created the isosceles triangle. So those are all the possibilities that I can use to solve my problem. So now it's time to have a look at our equation after we have picked up the important pieces of information. So we are going to calculate with reasons the size of PQS. So I'll go to my diagram and check what is PQS. So PQS means I'm looking at this angle. PQS. So I'm having a look at that angle. So looking at where that angle is, I will now try to go through the information I see to see which one can easily guide me through. Since I'm seeing a tangent and I'm seeing angle TPS as 23, I will need to check where does it exist. 23 exists between the tangent and TP in the chord PS. So that is the possibility of tan chord theorem, because there is a tangent and a chord. So to prove that tan chord theorem exists here, I need to use the chord as the base of the triangle, and I move in a triangle and see if I will get to the circumference. You see, I get to the circumference exactly at Q in triangle PQS. So it means I can easily get PQS through the tan chord theorem. So through the tan chord theorem, I can see that my PQS is exactly 23. That was given as TPS. So my reason here is tan chord theorem. So with this, I'm done with the A part, and now I'll go to the B part. But before I move to the B part, to make life easy for me, since I've succeeded to calculate PQS to 23, you can go to your diagram and put your 23 there, so that when you are looking at the others, it can easily help you to move on with the others, as long as you see that 23 in your diagram. So our next target is POS. So POS means we are looking at the angle at the center. You see, we have POS means we are targeting the angle at the center. So targeting an angle at the center already should be directly towards a theorem that talks about the center of a circle. And that theorem says an angle subtended at the center is twice the angle at the circumference. So how do you get that? There must be a chord like PS that will move in a triangle to the center. And if that same chord can move in a triangle to the circumference, that takes us to Q there, then you will see that the angle POS at the center must be twice the angle at the circumference, because that angle PS is the angle subtended by an arc. So when you see an arc, it's because there is a chord. If the arc subtends an angle at the center, then that same arc subtends an angle at the circumference. The angle at the center must be 2 times the angle at the circumference. So you see that by putting that angle there, it helps us to see the other one. But if you didn't put it, your diagram might become too vague for you to pick out the information. So from here, POS becomes very easy for me. So POS is supposed to be 2 times 23, and what is my reason? Angles at center equal to 2 times angles at circumference. So this shows to me that POS is equal to 46. So we are subject with POS, and we are free to go to our diagram and put our 46 so that it can help you now to get the next angle. So this is the little technique that if you master it, solving theorems of geometry can be very, very easy for you. So let's look at the last part of that problem. We need angle PRQ. So I need to go to my diagram and see where is PRQ. That is PRQ. So my PRQ is here. That's what I'm looking for. So if I go back to my hint that I've been working with, I will see that I've made use of 23. I've made use of the term chord. So since I'm looking for PQR, I can then look through my hints, the items I picked from my diagram, and see what have I not used yet. You realize I've not said anything about diameter. I've not said anything about isosceles triangle or the radius. So that should now narrow your reasoning, your mind to those 2 theorems. You look for the theorem of diameter to see if can it take me here to PRQ, or if it's not working, you try isosceles or maybe the tangent, but you see that the radius, radius, not tangent, you see that the radius is actually what took you to isosceles. So it's like these 2 are working together. So looking at my diagram very well, if you see where PRQ is, you see it should be having a relationship with PSO, because based on the chord PQ, that is a minor segment, this is a major segment. So based on chord PQ, you can use chord PQ to move in a triangle to position S on the circumference. The chord PQ again, you move in another triangle to position R. So you see S and R are angles in the same segment. That therefore means if I can succeed to calculate angle S, then obviously I will know R. But angle S is found in which triangle? QSP. And can you see QSP is a triangle subtended by a diameter, because SQS is a diameter. So that really helps me to get angle S. So I will start by saying QPS is equal to 90 degrees, and that is angle in semicircle. And that is another way of saying angle subtended by a diameter, because we know when there is a diameter in an equation, it divides the circle into 2 parts. One part is a semicircle or half a circle. So since O is at the center of the circle, then we can agree that QPS is 90 degrees, so it's a right angle. So that now takes me to angle S. So I can now look for that triangle QPS and say Q that we're looking for is the same thing as angle S, which is 67 degrees. And as we all discussed, we all agreed they are angles in the same segment because that chord PQ has created this major segment and that minor segment. So from chord PQ, you can move to the circumference in the triangle, and from chord PQ again, you move to the circumference in another triangle, and those two triangles are in the same segment. So these are angles in same segment. So that's how we go through that problem. So if we are fine with that, we can now look at the last one. So in this last problem, there are a good number of things I picked here. I see the circle. The circle has a D, E, F, G in the circumference. Then that is not all I picked. In that question, I see what else? I see that there is a cyclic quad. How do you know you see a cyclic quad? You see a shape with four sides inside the cycle with all the four edges or corners touching the circumference. So I'm seeing a cyclic quad in the diagram. So if I were to pick out the things I'm seeing, I would say I'm seeing a cyclic quad in my diagram. I'm seeing parallel lines. We're told in the note that DG is parallel to EF. So that means when I'm solving, I should look at the theorems around parallel lines, like my F, U, and N, to take me through. F gives me corresponding angles, U is co-interior, N or Z is alternating angles. Then I see OD and OE are the radius, and that automatically makes DOE an isosceles triangle. So I'm seeing isosceles triangle. What else do I see? I see a lot of chord in the diagram. Obviously, there is no tangent existing here because there is nothing out of the circle. So basically, that is all we see. We see that O is the center. So if there is a center, there is a possibility of the theorem around the center. So by analyzing my problem, I'll be working around cyclic quad, parallel lines, isosceles triangle, theorems subtended by a chord at the center is twice at the circumference. So that's basically the things I will be guiding. So we can now talk to the question. It says calculate with results the size of the following G1. So we see where G1 is. So where G1 is, if I make use of the chord DE, you see the chord DE can take us to the center in a triangle, and the same chord DE take us to the circumference in another triangle, which takes us to G1. So we can say with the existence of DE as a chord, the angle subtended by the arc at the center must be 2 times the angle subtended at the circumference. So in that way, I'm seeing that G1 is equal to a half of 104 because the angle at the center is 104, and according to that theorem, the angle subtended at the center must be twice the angle at the circumference. So G1 is half of 104, and half of 104 is supposed to be 52. So my reason is angles at center is equal to 2 times angles at circumference. So that is how I get my G1. So just like we can see in the other problem, if I succeed to calculate an angle, it's advisable to go to that position and put that angle there, because certainly it will help you to see the next calculation. So the way we've got G1, I'm now putting my 52. So we now look at the next. The next says we need E3. So how did I get G1? To make use of the chord and not pick the center. So I've made use of angles at the center. So to get to E3, I should now be targeting either isosceles, parallel lines, or cyclic quad. So parallel lines, we saw that EF is parallel to DG, and E3 is part of the parallel line. So this makes it easy for us to create our Z. So if you create your Z, you see it covers E3 and 52. So E3 is in a Z, And once your angles are in a Z or in an N, you say they are corresponding angles. So I can easily see that E3 is the same thing as G1, which is 52 degrees. So those are alternating angles. So that's how easy it is that I'm done with that. So I'm done with parallel lines. So whatever I'm calculating should either be around cyclic quad or isosceles triangle. So we go to the next calculation, which says we need angle GDE. So before we go there, to make life easy, I'll also replace E3 by 52, since this might be of help when I'm doing the next calculation. So I'm now putting my 52 there in my diagram. So you're free to always do that in your diagram when you are doing your calculations, since it might help you to see the next the direction you are moving to. So we now get GDE, and how is which one is GDE in my diagram? It starts with G, then I move to D, then I move to E. So it's describing the whole of that angle D, or D1 and D2. So I need the whole of that angle. So to get the whole of that angle, looking at my hint, I will target cyclic quad or isosceles. So that if you check, you see that the whole of that angle is not in a triangle. So I will certainly sit on cyclic quad. And the theorem of cyclic quad says the opposite interior angles of the cyclic quad are supplementary, to say the sum up to 180. So that will be telling me that the GDE plus 114, you see angle F, where you see F is 114, is equal to 180. That is opposite angles of cyclic quad. That is our reason. So from here, you can now get the meaning of GDE. So GDE is simply a 180 minus 114. So we get 180 degrees minus 114. That takes us to 66 degrees. So we're now at 66 degrees for that one. So we can now move to the last one, D, which requires us to get E2. So before we go there, if we're looking at our hint again, you see that we are done with cyclic quad. So getting to E2, it's obvious that we have to certainly make use of isosceles triangle to help us out. It might not be the only thing, but you certainly have to make use of this guy, because why did they give it to you if you want to make use of it? So looking at where we are, E2 is certainly here, but how do I make use of isosceles? If I'm looking at isosceles, DOE is isosceles. That tells me that E1 and G2 are the same. Then knowing that at the center there is 104, it means I can easily calculate E1 and G2. And also considering the fact that these two lines are parallel, then I can make use of a U there to get E2, because if I get E1, then I already know this angle. I've already calculated it to be 66. That one is calculated to be 66, then those are in a U, so we can use co-interior angles since those lines are parallel. So that's how we interpret it. So I'll start by saying my E1 is equal to G2, because I'm seeing isosceles triangle DOE. And luckily enough, the angle at the center is given, which therefore tells me that if I'm adding inside triangle DOE, I can therefore say 2E1 plus 104 is equal to 180. That is sum of interior angles in a triangle. So that's what I get. So that is certainly going to get me the meaning of E1. So to get my E1, I subtract 104 from 180, then divide by 2. So I'll get 180 minus 104, gives me 76, and divide by 2. I get my E1 as 38. So my E1 is 38. So if I now work in a U, since EF is parallel to DG, I will be saying, therefore, GDE plus E1 plus E2 but E1, you see we've calculated it already to be 38. That's plus E1 because I'm trying to add this angle to that one because they are co-interior, plus E2, which I'm looking for, plus 52. You see that if I just replace E3 by 52, I might be a little bit confused. Plus 52 is equal to 180. So those are co-interior angles because they are in a U since those two lines are parallel. So from here, DGE, I don't know why I wrote it as GDE because we already calculated GDE to 66. We just have written it as 66. So that is referred to GDE as 66. E1, we've got it as 38, that is it. E2, then plus 52. So if you look at this equation, you see that E2 is the only thing that you don't know in that equation. So if you calculate E2, you take 180 minus 66 minus 38 minus 52 degrees. So I'm taking 180 minus 52 minus 38 minus 66. So that gives me my E2 as 24 degrees. So, ladies and gentlemen, that is how we approach problems of theorems in geometry. So I guess that helps you. Thank you very much.